this is being recorded if you're at home, and we are doing, so I've recorded the fact that we lumped up Ridley and basketball, but ready? This is 10-1 beta. We're going to start with the PowerPoint. And we're saying this. The null is the difference of the two proportions. So we call them piece of one and piece of two. I don't really use numbers for those. I would use some like abbreviation for what the proportions represent. You'll see, it's up to you. You can't just say P1 and P2 unless you identify what 1 and 2 represent. I think it's easier to write some abbreviation. Now, we're always, not always, but every time for you, moving forward to this AP test, we're looking for 0. Why? Because then the two proportions would be the same, and there'd be no difference. So it doesn't matter whether it's a test or a confidence interval. We're testing whether the difference between the two proportions is 0. Well, that's another way of saying they're equal. So when I started to do this 13 years ago, I used to write the null this way. The two proportions are equal. But I've evolved to write it this way because it's more helpful to you because you know that you're looking for the 0. Because if they're equal, then the difference between them is 0. So you can write them either way. They're equally correct. But the way on the left gives you a prompt. And it's telling you you're looking for 0 as the difference. Now what? There's the conditions. And this has been really helpful. I think what's helpful is, like, reminding you what you're accountable for. So you're accountable for this so far. What are the critical values, the z-scores, for a 95% confidence interval, a 90% confidence interval, R squared, and p-value. And you get asked these repeatedly, you should know what they are, okay? So we'll let you go, anyone who's confident about any of the 4 of those. Because you have no wall. I don't recognize people aren't on their seat. McGarry.
R squared is a proportion of change in the output that can be attributed to change in the input.
Very good. No, that's your seat. Well,
am I supposed to give the number for the confidence intervals?
Yeah.
So 95 is like 1.96 and 90 is 1.64.
Right. Ready? So for 95%, the critical values would be 1.96 left or right of the center. At 90% would be 1.645 left or right. And the p-value, anyone? Don't break eye
I know.
That is, the p-value is the proportion. I know, but I do it anyway. The p-value is the proportion, I'm sorry, the probability of getting the test statistic you got or more extreme. And that's why the curve shaded in. You'll see that today. More extreme by chance alone and the null been true. Well, those things you should know from me repeating. The conditions you should know because they get repeated on the PowerPoints all the time. SRS, the sample's less than 10% of the population, and all these ratios are greater than 10, or at least 10. So here's the problem. Now, when you get a question like this, in the paragraph, you need to do this. You need to build a two-way view. Because you trying to go and get that information from the paragraph is confusing. So take a moment and read the question. You see what happened? There's the two-way table. And it would take you, I don't know, a couple minutes to summarize the information in two-way table. But if you don't do it and you try and get the information in the question, you kind of get lost. So it says state the hypotheses and check the conditions. All right, we got the table together. Now we go here. The null is there's no difference between the proportions of kids that miss breakfast between the two schools. No difference. That's the null. The alternate is there is a difference. See, it's a two-tailed test. They're not claiming that one school is neither than the other. Like, is this school doing a better job feeding their children? Or is this school doing a worse job? They just say, is there a difference? What about the condition? What about conditions? SRS, right? They tell you that there's more than 1,500 kids at each school, so we have less than 10%, and all those numbers are greater than or equal to 10. So the conditions have been met, right? And this is a little awkward now because then they leave the data. They leave the data, so we're going to leave the PowerPoint. Okay? Take out your calculator. And if you're at home, take out your calculator. And go to stat. Now, ready? This is done after you write the null and alternate and you write the conditions. Because the information I got, meeting with a representative college board, was lots of kids can do what we're doing now, use the calculator, but they get docked credit because they skip the hypotheses and they skip the conditions. So you essentially, there's 4 points on the AP test for an inference question. Conditions, null and alternate, test statistic and p-value, which we're going to do now, the calculator does for you, and then decision, reject or fail to reject. So if you just go right to your calculator, your ceiling is going to be a 2. Well, you're not going to hit your goal getting 2s. You have to remember to write the null and alternate and the conditions. So you do that first. So I'm going to go here. Stat, test. Now, look at all this stuff to choose from. Well, first off this. We're comparing two proportions. Proportions go with Z. Means go with T. So that's telling us to choose 6. Now, I loaded this up already from early this morning with the data. Ready? 19 out of 80 missed breakfast in school 1. 26 out of 150 missed breakfast in school 2. It's a two-tailed test. You only know that because you wrote the null and alternate. Either they're equal to 0, the difference, or not equal to 0. Then what? Well, we're going to go here. Second quit. Zoom, memory, recall. And you should have that picture because we stored a window in the fall. There it is. So if you don't have that window under Zoom, memory, recall, then type it in your type it in your window right now and push Zoom, memory, store. There is no reason for you to touch this window. You want to play with it during the summer? Go to town. You need this window if you're going to draw the curve for the tests. So I'm sure I got the window. Second quit, stat test, 6. And you can calculate it, but it's more helpful, especially in terms of the definition of the p-value, to draw it. Now what? Well, it tells me the p-value is 0.24. The p-value is relatively large. But think about the definition of p-value. It's the probability of getting what you got. What did we get? We got 1.683. There's 1. This is 1, essentially 1 to 6. We got 1 to 6. But what happened? It was a two-tailed test. So the calculator reflected it over the y-axis. The probability of getting a test statistic that we got that or more extreme, that's why it's shaded, or more extreme, by chance alone had the null been true. So what happened? We compare that to the alpha level. 0.24 is higher than 5%. F2R. Ready? We only reject the null if we're far from the center, if we're in the tail. We have to be less than the alpha level. But see, like this is pretty well shaded in that curve. Meaning all this is going to happen by chance alone. The null were true, and that doesn't meet the threshold to reject the null.
What's F2?
Fail to reject. Because what did we actually do before? You said build a two-way table that said this. The null could be true or it could be false. For our decisions, reject the null or fail to reject the null. Now what happens? If the null is true, and we fail to reject it, that's good. If the null is false and we reject it, that's good. These two are problems. They're errors. So we call this F2R, because if you F2R, the only error you can make is a type 2. That means this has to be a type 1 error. F2R means fail to, this is where they got FTK. Like the AP stats students were in fine. And then we get F2R, and they said, ooh, we can change that to F2K. I'm like, you can have it, because then it helps people remember it better when they're taking the statistics exam. So now what? Well, we left that data. And you're looking at this. Oh, well, now watch the slide. But you may be tempted to replace this with p hat. You're not even going to do this. Like, don't worry about it, that minutia. You're going to put it in your calculator. It's enough work to get the critical value in the p-value and interpret it correctly. Like, don't have a meltdown because they're saying, don't put p hat in the formula. You're not going to use the formula. You're not going to do it the long way. So what happens here? They're saying, we're not going to do. We're never pooling data. All right. So this is the problem you just did. They made a two-way table. It says, what conclusion do you make using alpha's 5%? Well, the difference in their proportion is 6%. That's literally the difference in the two proportions. But is that large enough to land in the tail? And we saw already that it isn't. So there's the 1.17, which is our z-score. So if I go back here, this is what the calculator did for you. All this mess. When you went to stat test 6, it did this work for you. Thank you. Thank you, TI. Now, what happens? They're saying, if you don't do stat test 6, you can say, what's the area of the curve? Normal CDF. And they pick from there to an arbitrary large number, and then they double it because you reflect it over the axis. You don't want to do that because it's just there's too many places you can make a mistake. You need the same answer. You'd rather just use stat test 6. There are no non-calculator components in the stat test. In that, we failed to reject the null. There's a lack of evidence of a difference of kids that missed breakfast in the two schools. And then here's what we did. And what happened? Instead of graphing it, they choose calculate. It's just not as visual. So you got the p-value. You got the p-value, 0.24. That's all you care about. Compare the p-value to the alpha level. But I just think it's easier to see it if you see it in context of the curve. I'm not worried about this. Okay. There's your z-score. How about another test? If you see me do this, that's why I told you with the nurses during class. Okay? Why would you laugh at that? That would be serious. All right. Now, so we have to build a new two-way table. All right. From the paragraph. Don't be presumptuous about this. You got the word from, you got to build the two-way table. Now, for the calculator, the two-way tables are like that. We don't need to know the nodes. We're not putting that in there. Yes? We're putting success, and success is you have a heart attack in this context of this question. We're putting yes over the total. So the null is the proportion of heart attacks between the treatment and the placebo is 0, the difference in the two. The alternate is, Ready? Do the results give convincing evidence at the 1% significance level? Why? Because it's a lower level, Mallory, and anybody in med tech, if it has to do with a medication. Don't just use 5%. You have to come up with a more demanding tail, like the more demanding tail. That this is effective in preventing heart attacks. So in this case, your alternate would be a one-tail test. Go to your calculator and load up the data and see if you did this correctly. Right, so we load the numbers, right? But what am I going to do? One-tail test. I'm testing to see if 1, which was the treatment, and 2 was the placebo. We want the treatment group to have less heart attacks. That was the whole point of the treatment. So I got to pick P1 is less than P2. Now, a couple things. You might not have that picture. Who doesn't? Cox wouldn't. Why? And that's why you're going to be following this, because if you're using an antiquated, you don't see the picture. If you're using the antiquated calculator, you need to clear draw between the two. But apparently, by the time they got to the newer calculator, they put that in there. And what I'm saying to you is you drew the one problem after the other, that's all it's shaded in. Because the calculator, this is a newer calculator. It knew to clear the draw. The older calculators, you might still see that shading in from the problem before. And that'll be misleading. Because you can see, look at, because these numbers will be right, but you've got to draw into the picture. And if it just overlaps from the previous picture, it will be deceiving. And you see what? The p-value is less than the alpha level. That number is less than 1%. So we would reject the null. Reject the null is there's no difference. Whoa! You found something. This drug is effective in preventing heart attacks. Your children's education is paid for. If you find something like this, it's like finding the COVID drug. You just go right to the bank. But that's why people are tempted to reject the null, because you can make money rejecting the null. But you can't reject it unless you literally land the tail. It's unethical. You just play with data until you find something you can reject. All right, so there's the null. The difference is 0. The alternate is it's less than 0. 1% is the significance level. What happened? We got negative 2.47 as the z-score, which you saw. But all this work, nobody wants to do this by hand. That test 6 does it for you, but you have to know what it's doing. because College Board recognizes that you're not going to use or that you are going to use a calculator. So they're going to word the prompt so they can tell whether you know what you're doing or just pushing buttons. Reject the null. There is evidence that this stuff works, okay? And then back to the beginning. So we're going to do one data set. And I'm saying this, ready? Here is your null. P1 taken by P2 is 0. It's the same thing as saying they're equal. So you've got a problem, 15 and 19. It is, ready? 15 and 19 is one data set. You're just going to do this, like the conditions, null and alternate, and then go to your calculator.